Let us now consider sample problem number 5. So for this example, same pa rin yung cross-section ng beam natin. So meaning to say, parehas pa rin yung value ng mga C natin. So we have 101.786 from the bottom to the neutral axis. And from the neutral axis to the top, that is equal to 198.214 mm. So, yung nag-iba lang for this example, siyempre yung loadings natin. So, right now, we have an overhang beam. So, it is overhang at 1 meter. So, yung distance between supports natin, that is equal to 4 meter. And yung sinusuportahan naman yung loading that has a value of W. So, for this example, so yung value ng W natin, so we're going to solve that in terms of Newton per mm, or by default, Newton per mm, that is also equal to kilonewton per meter. So let us now solve for the value of your W using etong mga allowable stresses natin. Determine the uniformly distributed load that the beam shown can carry if the value of your bending compression will not exceed to 100 megapascal and the value of your bending on the tension side will not exceed to 45 megapascal and dun naman sa shear natin will not exceed to 0.80 megapascal. So, ito yung mga allowable stresses natin na i-equate natin sa mga actual stresses natin to solve for the value of your W. Siyempre, to solve for that, we must know the value of your Vmax and the value of your Mmax using muna etong shear and moment diagram natin. So let us solve for the value of your R1 and the value of your R2 by means of summation moment. So summation moment muna tayo sa R2 to solve for the value of your R1. So let's say na clockwise is positive. So we have R1 multiplied by, so in terms of mm na lang para hindi tayo magkalito-lito. So sabihin natin we have 4,000 mm minus etong W natin, so W multiplied by yung kabuuan niya, which is equal to 5,000 multiplied by yung moment arm niya. So yung kalahati ng 5 natin, that is 2,500 minus natin yung 1,000. So yung distance nung uniformly distributed load natin with respect to R2, that is equal to 1,500 is equal to 0. So the value of your R1 is now equal to 1,875 W. So if we will take summation forces, vertical is equal to 0, upward positive. So yung value ng R1 natin, that is 1,875 W plus the value of your R2 minus W multiplied by 5,000 is equal to 0. So the value of your R2 is now equal to 3,125 W. So after finding for the value of your R1, which is equal to 1,875 W, and the value of your R2, which is equal to 3,125 W, we can now calculate for the value of your shear diagram and moment diagram. So for this example, hanapin muna natin yung shear diagram natin. So syempre, we will have, so at this point, meron tayo. So let's say ito yung mga points natin. So we have point A, point B, and point C. So at point A, tataas yung diagram natin ng 1,875W. Siyempre, so next naman, from point A to point B naman, so makaka-encounter tayo ng W multiplied by 4,000. So 1,875W minus W multiplied by 4,000. So you will have a value of negative 2,125W. So meron tayo dito na negative 2,125W. So ito na yung magiging shear diagram natin. So next naman meron tayo ditong pataas na 3,125. So yung mangyayari lang naman yan, negative 2,125 plus 3,125. So you will have positive 1,000W. So meron tayong value dito, which is equal to positive 1,000W. So from this, meron tayong makaka-encounter na pababa na W. So negative, positive 1,000W minus 1,000W. So yung value natin dyan is magsi-zero. So yung shear diagram natin, eto na ngayon siya. Since nagkaroon tayo ng zero shear, so kapag nagkaroon tayo ng zero shear, meaning to say, nandoon yung maximum moment natin. So for this example, dalawang beses tayong nagkaroon ng zero shear. First is dito sa point na to, at saka dito sa point na to. So for this one, yung tendency niyan is possible na at this point or at this point, nandito yung maximum moment natin. So, let us consider yung zero shear natin. I-reflect natin siya pababa to calculate for the value of your Mmax. So, let's say this is the value of your X. So, meaning to say yung matitira, that is 4,000 minus X. So, for this one, let us calculate for the value of your X. So, by similar triangles, we can now calculate for the value of your X. So, for that, i-consider natin yung small triangle at saka yung big triangle natin. So, we have the value of your X over yung height niya na 18,075W is equal to, so yung buo natin which is equal to 4,000 over yung tangkad ng malaking triangle natin, kasi consider natin triangle etong buong to. So mangyayari 18,1,875 plus 2,125, so you will have, so W plus 2,125W. So, mangyayari niyan, yung value ng W natin, makakancel lang yan. So, matitira na lang is yung value ng X natin, which is equal to 1,875 mm. So, for this one, meron na tayong value ng X natin. So, makukuha na natin yung mga values ng mga moment natin. So, let us consider at zero shear, that is our point P. So, for this one, wala naman tayong moment at A. So, the value of our moment there, that is equal to 0. So, at point A, that is equal to 0. And A is 0. So, next naman is yung point D natin. So, mangyayari niyan, that will become 0 plus etong shear area natin. So, meron tayong 1/2. Yung base niya is yung x natin, which is equal to 1,875 multiplied by yung height ng triangle natin, which is equal to 1,875 W. So the value of your MD is now equal to 1,757.8125 times 10 raised to 3 W. So, mangyayari niyan, yung diagram natin, since nag-decrease yung value ng shear natin, so sa-sad face siya. So, this is yung value ng MD natin. So, next naman, for the value of your MB, so that is equal to MD na 1,757.8125 times 10 raised to 3W minus the value natin na negative shear area. So, we have 1/2. So, yung base niya, that is 4,000 minus x, which is equal to 2,125 multiplied by the height, which is equal to 2,125 W. So, the value of your MB is now equal to negative 500 times 10 raised to 3 W. So, nangyari niyan is nandito yung value ng MD natin. So, this is the value of your MB na negative. So, lastly, for the value of your MC. So, MC that is negative 500 times 10 raised to 3 W plus etong maliit na triangle natin na 1/2 na merong base na 1,000. So, na merong height which is equal to 1,000 W. So, the value of your MC is now equal to 0. So, since nag-decrease yung value ng shear natin, siyempre mag-sad face yan. So, this will now become your moment diagram. So, yung kinaibahan lang ng problem number 5 natin, for this example, yung kinaibahan niya o yung differences niya sa mga previous example natin. So, for this one, nangyari is meron na tayo negative moment. So, ano nga ba yung ginagawa ng negative moment natin sa beam natin? So, kung yung positive moment natin, yung ginagawa niya is pinapangiti niya yung beam natin. When we are dealing with negative moment, yung ginagawa naman niya is pinapalungkot naman niya yung beam natin. Or if we were going to say it sa technical term natin, kapag sinabi nating positive moment, so for the positive moment, so yung curve natin or the elastic curve natin, that will become concave upward. And for the negative moment, mangyayari naman that is concave downward. Kaya yung tendency is, pangingitiin niya yung beam natin at palulungkutin naman niya. So for this, let us explain kung paano ngingiti at saka kung paano malulungkot yung beam natin. So, siyempre, kapag nag-shift tayo from positive moment to negative moment, magkakaroon tayo dyan ng zero coordinate. O ito yung tinatawag nating zero moment. Or yung commonly tinatawag na point of inflection. Kapag nasa point of inflection ka, the value of your moment is equal to 0. So for that, sabihin natin na hanapin natin yung value ng point of inflection natin from R1. So paano natin hahanapin yung value ng Z natin? So for this one, i-apply lang natin yung yung principle natin. So, mangyayari niyan is magkakat tayo ng section. Magkakat tayo ng section dyan. So, meron tayo dito na R1, which is equal to 1,875W. Tapos, nandito si Z. So, ikakat natin yan. So, meron tayong W dito. So, hanapin natin yung value ng M natin dyan. So, for the value of your M, considering left section, so, mangyayari niyan, that will become M is equals to summation moment. So, since left section yung consider natin, that will become clockwise is positive. So, we have M is equal to 1875W multiplied by Z minus etong uniformly distributed load natin na W multiplied by Z over 2. So, para mahanap natin yan, isa-set natin yung M natin ng 0 kasi nga 0 moment. So, mangyayari yan, ta-transfer natin etong port na to sa kabila. So, we have W Z squared over 2 is equal to 1875 WZ. So, mangyayari niyan is makakancel yung value ng W natin, maiiwan yung isang Z, and we can now calculate for the value of your Z, which is equal to 3,750 mm. So, at 3,750 mm, so nandoon yung location ng point of inflection natin. So, let us explain kung paano magbe-behave yung beam natin. So, for this one, so by theory of structures, so, gagawin natin is, i-reflect natin yung point of inflection natin dito sa beam natin. So, reflect natin yan pataas. Ayan. So, kapag sinabi natin point of inflection, doon, nagkakaroon tayo ng shifting. From concave upward, ginagawa natin siyang concave downward. So, pakita natin, no? So, yung ginagawa natin, nagkakaroon tayo ng mga supports. So, meaning to say, sa mga supports natin, 0 lagi yung deflection natin. So, from this part, so, since meron tayong positive moment, so, mangyayari niyan is, pangingitiin niya yung beam natin. So, ngingiti yung beam natin yan. Ayan. So, at that point naman, at this point, tapos na yung positive moment natin. So, from this point sa point of inflection natin, from happy phase, gagawin niya yan is palulungkutin niya yung beam natin. So, from this point, so, mangyayari niyan is magiging sad na yung phase ng beam natin. Tapos, tuloy-tuloy lang siya. So, pinadaan natin siya dito sa support kasi nga magzi-zero siya. So, mangyayari niyan, ganito yung elastic curve ng beam natin. So, ginawa ko lang dito is in-exage ko lang yung drawing para makita ninyo yung differences. So, eto concave upward, tapos eto naman that is concave downward. So, meaning to say, nandirito yung deflection natin, which will be discussed sa theory of structures natin. So, meron kayong different methods to solve for the value of your deflection. So, ganun lang yung principle natin when we are encountering positive moment at saka negative moment. So, for the sake of discussion, we will going to consider etong dalawang moments natin. So, we have yung positive moment, yung positive Mmax natin, which is equal to 1757.8125 times 10 raised to 3W, and yung negative Mmax natin, which is equal to negative 500 times 10 raised to 3W to solve for the value of your W. So, ipapakita natin yung differences between these two. So let's start. So first, we will going to explain kung paano nag-a-occur yung compression at saka tension natin. So for this one, kapag sinabi nating positive moment, as stated nga, di ba? Kapag positive moment, pangingitiin niya yung beam natin. So we have a positive moment which is equal to 1,757.8125 times 10 raised to 3W. So yung ginagawa ng positive moment natin, pinapangitiin niya yung beam natin. So yung tendency, since pangingitiin niya yung beam natin, therefore, yung nasa taas natin, kung titingnan nyo dito, that is in compression. Yung nasa baba naman, that is in tension. So this is our neutral axis, yung nasa gitna natin. So kung illustrate natin yan sa ruler, so pag ganito yung mangyayari niyan. So next naman, sa negative moment naman natin. So negative maximum moment natin is 500 times 10 raised to 3 W. So magiging sad yung beam natin. So yung tendency niyan, yung nasa taas natin is compression, is tension. Yung nasa baba naman is in compression. Katulad ng nangyari sa part ng beam natin dito. Nandito yung tension, nandito naman yung compression. So let us consider both case. So meaning to say, kapag kinonsider natin yung positive Mmax, so mangyayari niyan, iba yung compression natin, iba yung tension natin. So consider muna natin yung Mmax natin. Positive Mmax. So we will have a value na 100 daw megapascal. So the value of your Mmax is 175 times 10 raised to 3W. And the value of your C sub C dito, that is equal to, so compression muna tayo, that is equal to 198.214 over yung I natin. So yung I natin, same lang siya nung kanina, since inadapt lang natin yung cross-section natin. So yung I natin, that is equal to 199.135 times 10 raised to 6 millimeter to the fourth. And for the value of your Q, so same pa rin yung value ng Q natin. So this is 199.135 times 10 raised to 6. So yung value ng W natin is now equal to 57.153 Newton per mm. If we will consider naman yung tension naman natin, so we have 45 is equal to, so we have 1,757.8125 times 10 raised to 3W, and the value of your C in tension, that is equal to 101.786 all over yung I natin, which is equal to 199.135 times 10 raised to 6. So the value of your W is now equal to 50.084 Newton per mm. So how about naman etong negative Mmax natin? So mangyayari lang naman yan is we will have same lang naman yung allowable natin. So magkakapalit lang yung Mmax natin times 10 raised to 3W. And for the value of your C here, so in tension side natin, that is equal to 101.786 all over yung I natin na 199.135 135 times 10 raised to 6. So the value of your W is now equal to 391.282 Newton per mm. So next naman, we will going to consider yung compression naman natin na 45 megapascal. So yung negative Mmax natin na 500,000 times 10 raised to 3 W. So yung C natin naman dito, ito namang 198.214 all over yung I natin na 199.135 times 10 raised to 6. So the value of your W here is now equal to 90.418 Newton per mm. So na-consider na natin yung compression side at saka yung tension side natin. Consider yung positive Mmax and the value of your negative Mmax. So lastly, we're going to consider etong FV natin. So for that, so meron tayong 0.80. Yung V natin, so yung Vmax natin, as stated, ito yung Vmax natin, which is equal to 2125W. So that is 2125W. The value of your Q, so in-adapt lang natin to sa mga previous problems natin na 982.227 times 10 raised to 3 all over yung I natin. So 135 times 10 raised to 6 and the value of your B na dinaanan ng neutral axis natin, which is equal to 50. So the value of your W here is now equal to 3.816 Newton per mm. So, ano yung i-adapt nating values dyan? Okay? So, kapag compare muna natin etong values natin sa positive moment natin at saka sa negative moment. So, for this example, meron tayo dito na 57.153 on the tension side sa positive moment and 50.084 naman sa compression side versus 391.282 at saka 90.418. So, sobrang laki ng mga differences natin. So, meaning to say, no, laging nag-govern between the positive Mmax and the negative Mmax, yung mas mataas yung magnitude. So for this one, mas mataas yung magnitude natin sa Mmax natin compared dito sa negative Mmax natin. And also, siyempre, by analysis din, depende rin sa bibigay na problems natin. But, at saka, sa mga values ng mga centroids natin. So, depende pa rin. So, for this one, so, mas mataas, mas mababa yung mga nakuha nating value dito sa positive moment natin. So, which means, mas safer etong mga loads natin compared dito. Kasi yung tendency kapag in-adapt natin yung mga values na to, mag-fail tayo dito sa part na to. So, nung kinonsider naman natin etong sa allowable shearing stress natin, nakuha naman natin etong 3.816. So, meaning to say, kapag loadings yung pinakamababa, yung i-consider natin. So, this will now become your answer. So, yung answer natin is 3.816 Newton per mm. So, that will be all for our problem number 5.